All right, I want to take a look at your calculator and see how it handles polar coordinates. So first of all, I'm going to go to the mode button and notice that I am in radians. And so what I want to do is I want to go down here, and there's this line that says function, parametric, parapole, and sequence. I want to be in polar mode, so I'm going to move over till it's on polar, and then I'm going to hit enter. Right, and then I can quit. Now your calculator has done several things by putting it in polar mode. First of all, this button here that says xt theta n, it's not going to be an x anymore, it's going to be a theta. A couple other things you may notice. If I go to the y equals, it's not y equals anymore, it's r equals. Likewise, if I go to the table, which is the second function of graph, then it has theta values here, and it will do r values there once I put a function in. Okay, so that's the basics of your calculator in polar mode. I want to actually look at some simple graphs. For instance, let's go back to the y equals here. I want to just look at something like, r equals a constant. What does r equals 5 looks like? Well, if I go to the table, it's going to be plugging in a bunch of different values for theta. Theta equals 0, 1, 2, 3, whatever. These are in radians. They're in radians because my calculator is in radian mode. And ours is always 5. Right? What does the graph of this thing look like? It looks like, it's supposed to look like a circle. Let me do a zoom 5 here. Okay. There we go. Zoom 5 is zoom square, so that all the pixels in the x direction are worth the same as the pixels in the y direction, and it gives you the true shape of things. So anyway, that looks like a circle. Right? Notice that just graphed a circle. I mean, I don't know if you can do that in x's and y's. Just r equals 5. We got a circle of radius 5 right there. So other things that I just thinking about it, if I take a look at the window button, the window button looks a little different. There's still x min, x max, y min, y max, right, y scale, but it starts off with some other things. This is doing theta min and theta max and theta step. That is, when it's drawing graphs here in polar coordinates, it's plotting certain values of theta and plugging them in and figuring out what r is, and then plotting those points. And so this is how it's determining that. Theta min is the lowest value of theta it'll choose. Theta max is the highest value, and theta step is the increment. So it's going to start at 0, and then it's going to go to 0.13, and then it's going to go to 0.26, and each time it's going to add whatever this number is on again. Okay. On the calculator, I can only draw graphs of r equals some function of theta. Let's try another one here. Let's just say r equals theta. What is that going to look like? I mean, if I look at the table, and pretty much every textbook is going to be drawing these graphs by looking at tables. They're going to plug in values of theta, figure out what r is. Well, I mean, it's not too hard to figure out that if r equals theta, then whatever theta you plug in, that's what the r value is. But what is that going to look like? As theta is getting bigger, r is getting bigger. You got an idea what you think it looks like? Let's take a look at the graph. Right. Did you guess a spiral? Right. When theta is 0, r is 0. By the time theta is pi over 2, and you're looking straight up here, r is pi over 2. When theta is pi, you're out here in the direction of the negative x-axis, so the direction of pi, and you go a distance of 3.14 in that direction. When you get to 3 pi over 2, you're going to be down here. When you get to 2 pi, you're looking in the direction of the positive x-axis again, and you go a distance of 2 pi, so just over 6. If I looked at more values of theta, so if I go here, if I change my theta max from 6.28, that looks like 2 pi, I'm going to change it to, oops, I'm going to do this by the calculator style here. I'm going to change this to 4 pi. 4 pi. Enter. Now I'll go back and look at the graph. Oh, it goes around twice. Right. Notice I haven't actually plotted any negative values for theta. And if I do that, you might try to figure out what you think it's going to do. When theta is negative, r will be negative. That's going to be weird, so we kind of plot behind where I think I'm looking. So let's go to the window here, and let's go from negative 4 pi to 4 pi, negative 4 pi to 4 pi. And look at the graph one more time. Spirals in and it spirals back out again. Right? Every textbook you'll ever see will do these by plotting points. They pick values of theta, they calculate what r is, and then they plot those points in polar coordinates. In the next few videos, I want to take a look at these things a little more holistically. I want to, rather than plotting individual points, let's see if we can look at the function, look at different types of graphs, and see if we can figure out what the graph of these polar equations look like. So anyway, there's your calculator. You have it available. Let it be a tool for you.